The distinct visual artifacts of mid to late 20th century television, such as magenta green fringing and vibrating rainbow-like smears, are not random. They are the direct results of structural limitations and engineering compromises required to transmit and record multi-layered visual data within restricted bandwidths. The NTSC, National Television System Committee, standard introduced color while maintaining backward compatibility with black and white sets by dividing the video signal into two components. Luminance, why? The high bandwidth black and white signal representing brightness and fine detail, and chrominance, C, the signal carrying color hue and saturation. In composite video, these components are multiplexed into a single channel. The chrominance data is modulated onto a specific color subcarrier frequency, 3.58 MHz, and superimposed onto the luminance signal. Because they share the same channel, the receiver must electronically separate them. This causes chroma crosstalk, cross-color artifacting. When a signal contains high-frequency spatial details, like fine text or patterned textiles, the luminance frequencies overlap with the color subcarrier. The television's decoder mistakes these rapid brightness transitions for color data. Because hue is determined by signal phase, this interference causes a 180-degree phase shift, manifesting as unstable magenta and green fringing along sharp edges. While composite artifacts stem from signal mixing during transmission, VHS tape degradation results from the mechanical and bandwidth limits of consumer hardware. Early VCRs could not support the high bandwidth required to record a standard 4.2 MHz composite signal directly. Engineers bypassed this using a down-conversion architecture called the color undersystem. The VCR separates the composite signal and down-converts the chrominance signal to a much lower frequency, 629 kHz, placing it under the luminance signal. This drastically reduces chromatic bandwidth. While luminance remains sharp, color resolution drops significantly, causing two distinct artifacts. First, horizontal color smearing occurs because the low-bandwidth chrominance channel cannot transition fast enough to keep up with sharp image boundaries, causing color to bleed or smear horizontally past the lines defined by the luminance channel. Second, rainbow-like chroma noise is generated. Analog video relies on precise signal timing, the phase angle of the color burst, to determine hue. However, VCRs rely on physical tape pulled by mechanical motors. Microscopic tape stretching and motor speed fluctuations, wow and flutter, introduce tiny timing errors during playback. These deviations constantly shift the phase angle, causing the bleeding color to cycle erratically through a spectrum of wavelengths and creating vibrating chroma noise.